Hello friends, myself Sachin Kumar. Today we are discussing about array concepts, and particularly we are going to discuss about address calculation, row measure and column measure concepts. What are these? We are discussing one by one. So before presenting it, if you are new to our channel, please like and subscribe. If we talk about the Bundy array, then we have here say integer a minus 1 to 5. Here first subscript starts with minus 1 and last subscript is 5. If we talk about the C programming array, the first subscripts always start with 0. But in general array may be start with any subscripts. It may be starts with say minus 5, minus 10, plus 2, plus 8, etc. So if we have here array integer a minus 1 5, it simple means first subscript is minus 1 and last subscript is 5. Then we can say upper bound equals to here 5 and lower bound equals to minus 1. Then if we talk about the size of this array, formula is upper bound minus lower bound plus 1, and we have here 5 plus 1 equals to 7. The size of this array is 7 and total memory is occupied 7 multiplied by 2 equals to 14 as integer take 2 bytes. So in this way we can calculate the total memory used by any one-dimensional array. If we talk about the two-dimensional array, then this is here 2D array and we have here total say 3 rows, row 0 row, first row and second row, and here we have 0 column, first column, second column. So we have total 3 by 3 matrix, and here this is here A00 means 0 row 0 column. This is here A01 means 0 row 1 column. 02 means 0 row second column. 10 means first row 0 column. 11 means first row first column. 12 means first row second column. So these are the conventions to call a particular location of the array. If we talk about the row measure concepts of the two-dimensional array, then uh, array is being represented in form of the rows. So first location of memory is reserved for A00. Next location of memory is reserved for A01. Then next location of the memory is reserved for A02. I mean array is stored row wise. So this is here 0 row. This is here 0 row first column, 0 row second column. Here we have the first row 0 column, first row first column, first row second column, second row 0 column, second row first column, second row second column. So this matrix is being stored row wise. So if we are able to store the matrix row wise, then this concept is called row measure representation. If we talk about the address calculation of row measure representation of two-dimensional array, so we have here formula. Formula is b plus w multiply n I minus L1 plus j minus L2. What are these? B equals to here base address of the array, and w is here size of each element. For example, we have the integer array, then size of the each element may be 2. If we have float array, size of each element may be 4. So in this way we can calculate the size of each element, and n is here number of column. So number of column is we can calculate u2 minus l2 plus 1. So what are u2 and l2 etc. we are discussing now. L1 is the basically lower bound of the row and L2 equals to lower bound of the column, and U1 is here upper bound of the row and U2 equals to upper bound of the column. So after placing these values on this formula, we can calculate the address of Aij location. Say this example is given and we have to calculate the address of any particular location. So we have here two-dimensional array. Array is here 4 to 7. I mean row starts with 4 and goes up to 7. Minus 1 to 3 means column starts with minus 1 and goes up to 3. Then here every locations requires 2 bytes. If array is stored in the row measure form, then calculate the address of element at location 62. So we have to get the location of 62 where base address is given by 200. So here given is here b equals to 200, L1 equals to here 4. I mean lower bounds of the row is here 4. L2 equals to here minus 1. Lower bound of the column is minus 1, u1 equals to 7, upper bound of the row is 7, u2 equals to 3, upper bound of the column is 3, and size of w equals to 2. We have to find out the address of A62, I mean I equals to 6 and j equals to 2. After putting all these values in this formula, we can get the address of our desired location. So here n equals to here number of columns. So number of columns means u2 upper bound of the column minus lower bound of the column plus 1. So we can get n equals to 5. So total we have here 5 columns are given. So if we give all the values, then we can get address of 2 is 226. So this is the here very simple method to calculate the address of any 2D array if we have the row measure representation. Now, if we have suppose column measure representation, so in the column measure representation, first location is reserved for A00, I mean 0 row 0 column, and second location is reserved for A10, I mean row is being changed, first row 0 column, here second row 0 column. So it simple means here we are keeping the elements in form of the columns. So this is here our column 1, this is here our column 2, this is here our column 3. So we can observe that in row measure representation we are storing all the elements row wise. In the column measure representation we are storing all the elements column wise. So if we talk about the address calculation of this column measure representation, then formula is b plus w m j minus L2 plus I minus L1, where b is given base address, w is here size of each element, m is here number of row. So number of row we can calculate the upper bound of row minus lower bound of row plus 1, and L1 is here lower bound of row, L2 is here lower bound of column, U1 is here upper bound of row, and U2 is here upper bound of column. So if we talk about the example of column measure representation, then we have here two-dimensional array minus 20 to 20, 10 to 35. I mean first subscript of the row is minus 20, last subscript of the row is 20, first subscript of the column is 10, last subscript of the column is 35, and each location takes 1 byte. So w is given here equals to 1. So if we array is stored in the column measure form, then calculate the address of element at location 030 and base address is here 1000. So base address is here 1000. L1 equals to here minus 20. I mean first subscript of the row, lower bound of the row is minus 20. L2 equals to 10 means lower bound of the column. This is here 10, and u2 u1 equals to 20. I mean upper bound of the row is here 20. u2 equals to 35. Upper bound of the column is here 35. W equals to 1 here, and we have to find out the location of 030. I mean I equals to 0 and j equals to 30. Now how we can get the number of rows? Number of rows equals to m. So u1 minus L1 plus 1. u1 is here upper bound of the row. L1 equals to here lower bound of the row plus 1. Then we get number of rows are equals to here 41. So here we have all the values, putting all these values into this formula, and we have the address of 0 and 30 equals to 1840. So in this way we can calculate the address of column measure representation. If we talk about a 3D array, then this is here suppose a 3D array integer 332. So we can represent this 3D array is the collection of 2D array. And say if we talk about first 0th 2D array, then we have here, you know, 6 locations for the 6 locations for the 0th 2D array, because here I mean here if we talk about the first 2D array, the size of each 2D array is 3 multiplied by 2, 6 size. So we have here 6 size of 0th 2D array, then next 6 size for the first 2D array, then next 6 size for the second 2D array. Therefore, this 3 size, this 3 size, we have here total 3 2D arrays. So we can represent 3D arrays as the combination, as the collection of multiple 2D arrays. So if we talk about the formula for address calculation of 3D array, then we have here array L1 to U1. I mean L1 is the first subscript of the row, lower bound of the row, and U1 is here last subscript, I mean upper bound of the row, and L2 is here, you know, this is the second array, and this is the lower bound of the second array, and this is here upper bound of the second array, and this is here upper bound of the lower bound of the third array, and this is here upper bound of the third array. As we have discussed, this 3D array is a collection of the multiple 2D arrays. So we have here total 3D arrays, total 3 2D arrays. This is the one 2D array. This is here our second 2D array. This is here our third 2D array. So here we have the various parameters. Parameters are D1. D1 means upper bound minus lower bound plus 1. So D1 is the size of this particular array. And if we talk about D2, so D2 is the size of this particular array. And if we talk about D3, size of this particular array. And W is suppose here size of each element. If we have the integer, then W is given 2. If we have the float, then W is given 4, etc. Now, if we have here say S2 and S1, etc., these are here basically size. So how we can get here this size? So S2 equals to this is here D3, and basically this is here our W. The W is here size. The size of a row is calculating here in the S2. So this S2 can be calculated by D3 multiplied by W. And if we talk about S1, S1 equals to D2. D2 is here size of second array, and S2 is here size of plane, and size S2 we have calculated using this formula. If we talk about the address calculation of IJK array, then formula is given by base address plus I minus L1 multiplied by S1 plus J minus L2 multiplied by S2 plus K minus L3, and finally we are being multiplied by